In this video for section 3.3, we're going to talk about the empirical rule. And we use the empirical rule when we have a bell-shaped distribution. Bell-shaped means that it's symmetric, with a peak in the middle and tails on both sides. If we have a bell-shaped distribution, about 68% of the values fall within one standard deviation of the mean. So the mean is marked here with this red line. This dotted line is the mean plus the standard deviation, and this dotted line is the mean minus the standard deviation. 68% of our data values will fall between those two lines, or about 68%. About 95% of the values fall within two standard deviations of the mean. So this dotted line is mean plus 2 times the standard deviation, and this dotted line is the mean minus 2 times the standard deviation. 95% of our data values fall between those two dotted lines, with only 5% of the values outside of that area. Virtually all of the values will fall within 3 standard deviations of the mean, or about 99.7%. So we're going to do this problem with Eddie's Burgers. They recorded the number of chili burgers sold each day for the past 365 days. Do the data seem to come from a bell-shaped population? So what we need to do to solve this problem is figure out how much of the data falls within one standard deviation of the mean and how much of the data falls within 2 standard deviations of the mean. And we can use that to say that if in fact that is the case, then yes, the data will follow a bell-shaped distribution. If the percentages are pretty far off from those percentages, then we would say no, it does not seem like the data are bell-shaped. So what we need to do first is calculate the mean and standard deviation of the data set. And I've already done that in Minitab. So this is the data set and we have the mean and standard deviation. What I need to do next is figure out what the mean plus the standard deviation and the mean minus the standard deviation is, and then figure out if 68% of the data is within that range. So I'm going to round these numbers to tenths. So if we take the mean plus the standard deviation, that's 15.1 plus 3.1, which is 18.2. And now we take the mean and subtract the standard deviation, 15.1 minus 3.1, and that equals 12. So approximately 68% of the data should be between 12 and 18.2. Now to figure out if that's true or not, I need to go back to my original data set. Now, this data set is pretty big because I have one value for every day of the year, or 365 values, which is a lot. I could go through and keep track of which ones are within that range and which ones are not. So for example, 14, 11, and 16 are within that range. 19, 19, and 20 are not within that range because my range is between 12 and 18.2. An easier way to do it is to have Minitab make a stem and leaf plot. And that will sort the data values and make it easier for me to figure out how many are in that range. So I'm going to make my stem and leaf plot here with an increment of 10. Now, this still is going to be a lot of work because there's a lot of numbers to count up here. But basically, I'm going to count starting with the 12s all the way up through the 18s and count how many numbers there are. Now, this will give you a headache, so I can just go ahead and tell you how many there are. There are 263 of the 365 numbers from 12 through 18. So, if I divide 263 by 365, I get approximately 72%, which is pretty close to 68. So far it's looking good, but let's keep going and test the 95%. So for the 95%, that's within 2 standard deviations of the mean. So what I would do is I would take my mean, 15.1, and add 2 times the standard deviation, which is 3.1. And if I do that, just use a calculator, I get 21.3. And then if I do 15.1 minus 2 times the standard deviation, 2 times 3.1, I get 8.9. So approximately 95% of the data should be between 8.9 and 21.3. So what I want to add up is how many numbers there are between 9, because 8 would be too small, and 21, because 22 would be too big. So how many values are between 9 and 21? Well, it's going to be easier for me to say how many values are not within that range. So if I go back to my stem and leaf plot, I see that I have 1, 2, 3, 4, 5, 6, 7 and 8, and 1, 2, 3, 4, 5, 22 and 24. And those are the only numbers that will not be in that range. So that's a total of 11. 365 minus 11 is 354. So 354 divided by 365 is a total of 97%. So 97% of the data is within that range, which is pretty close to that 95%. So again, that value tells me that this most likely is coming from a distribution that is pretty bell-shaped. Now I can try the 3 standard deviations. So if I calculate 15.1 plus 3 times 3.1, that's 24.4, and 15.1 minus 3 times 3.1 is 5.8. So any data values that are lower than 5 or greater than 25 would be outside of that range. And if I look at the data set, I don't have any values lower than 5 or greater than 25. So that tells me that all of the data is within that range. And again, what we said was that virtually all, or 99.7% of the data should be within 3 standard deviations of the mean. And again, that matches up with what we should have for a bell-shaped distribution. So this, I would say, yes, it is bell-shaped. That's my conclusion.